Who would like to pray? I'll bring up the eLearn page here. I'm playing with a variety of things. I've been learning about, or trying to do an Android game, multiplayer game, as our Visual Basic friends are wanting to do a Dutch Blitz game in Visual Basic. And I've been wanting to do something with the Android. It's not as easy as I'd like. You find examples, you get started on them, get all excited about them, and then halfway through it stops working. They say, oh, this should compile, and you try it, it doesn't.
That's what I started with my Java game. I started going through some stuff.
Yeah.
I was like, I don't think I'm going to start this yet. I need to learn some of the basics.
Yeah. And then you'll come to some blogger that says, oh yeah, do it this way. And they'll mention words you think, yeah, I know that's what I need to do, but nothing saying, okay, here's how I did that. Say, oh yeah, this worked great for me. Show me how you did it. What my problem is, on my Mac I have a variety of tools installed, and so they say you need this, and I'm thinking, okay, I might be able to get it to work, but I have to do it from scratch on another machine if I'm going to be able to help a student get to this point. Because over the years I've been installing all sorts of versions of Eclipse and Java, and I'm thinking, do I really know how to get what I have? So we're in section 4, requirements modeling, and as I was kind of reviewing the material here, I found a couple of interesting resources. One was one called Scrumology. It was kind of an interesting site. This guy is talking about software estimates, and the reason I came across this, I was looking for software for estimating the total cost of ownership, as mentioned in the book. They mention a Microsoft, what was it called? Microsoft's estimation. I couldn't find Microsoft software anymore. It used to be apparently a resource. The only place I could find it was in Office 2010 Resource Kit. Couldn't find it anywhere except in some site in Indonesia. And they didn't have anything to download. They just had a white paper explaining how if you pay them money, they'll help you do it. So this site talks about estimating agile costs, agile projects. Remember what agile is? Yeah, an iterative approach. Yeah, and it's one way. It's a popular way of approaching project completion. And remember, the whole waterfall approach, or the RAD, which is similar to the waterfall approach. It's all basically a way to discuss the various parts of a project, but every project you work on is they'll approach it differently as you come across different problems. But having at least a plan for approaching a problem systematically will give you at least a place to start. But at each problem, as you approach it, you might find, we got to do this iteratively, just because there's a lot of pieces here. Other problems, you'll come and say, we can start right away and go systematically through. Something like building a part in a machine. It's fairly straightforward. It's been done before. You have lots of ways of implementing it. There's not so many ways to implement it. You can approach it from one approach. Here we get the parts, or we get the materials, we make the part, and we ship it. This guy had a couple interesting comments as I was reading through this, where when they're estimating your project, the programmers kind of throw together their ideas. They estimate how long they're going to take on each project, and they apply some contingency factor. I'll zoom in a little bit there. To take in account any risk. Look at how you might actually increase your padding for a conservative estimate, multiply the total estimated cost by 2, 2.5. Usually, plus or minus 50% can be the variation. It's kind of scary when you're talking about this kind of large margin of error. But he's saying it's a good guess. Very much different from scientific estimates of things like the speed of light, where we have very close estimates. Interesting comment here as I was reading through his paragraphs that some people report that all of their projects are on time and on budget. Well, he's saying, you know what? They're usually fudging things when they do that. They're saying, yeah, we were we had our initial scope, but they'll say, you know, those extra things we didn't get done, we'll make those part of a separate project. So we can say this project was 100% done, which is a little bit fudging. Another thing he hates, that they'll say it's on time and on budget, but they've released a defective product. Just so you could say, yeah, we got it in on time and on budget. Oh yeah, we'll be coming up with version 2 in a few weeks. Sound familiar? Maybe Windows Vista, Windows 8, and then 8.1 came pretty quick. Big corporations even have to do that kind of thing because it's a big deal to get it there one time. Which was the one that was, what came after XP? Was it, yeah, Vista. They were promising a new Windows version for a long time. And people were, I think it was initially going to be called Windows 2005 or 7, and the years went further and further, and finally they gave it a different name. And I had some beta versions. I thought, man, my poor little XP machine could hardly run it. Even the beta version. One thing, let's see, he mentioned something about here. When you're quoting a project and looking at the total cost, how do you commit to a cost or even estimate it? You have to kind of say, okay, here's exactly what we're going to do so we can have a good estimate of our cost. Well, he's saying this, if you have a fixed price or a fixed scope, which I've always thought, you have to have a fixed scope. He's saying fixed price, fixed scope are often adversarial. Why do you think he says that? That kind of made me think, wait a minute, I've been wrong. I always thought fixed scope was great. How can that be adversarial? Any ideas why a fixed scope, fixed price might be adversarial? Right. Yeah, and with technology, sometimes you just change happens, and you just have to, maybe you have to somehow roll that in, and maybe have some boundaries around it. But I guess what he's saying is, if you say, oh, we're only giving you this and no more, and your customer says, wait a minute, we just discovered that our government requirements need this, and you say, nope, you're getting what we wrote on the contract, and you get very hard line with that, you can see that your customer might see you as inflexible, and that's where that adversarial part can come in. So that was an interesting comment I was reading through that, is wait a minute, I wasn't thinking of it as adversarial. I was thinking of, if you don't specify a scope, I was thinking that can become adversarial if later on there's a misunderstanding of what your scope was. So maybe to not have this scope creep problem is maybe in the scope you do have some contingency of, in case there were extra things come up, maybe instead of fixing the price, you might say if there's additional work as changes come along, maybe you could specify an hourly rate for the extra hours for adding those extra features, at least giving your customer a heads up. If there is something extra, let's specify that, okay, we'll do it, but we have to pay for our time as well, and there may be some adjustments to the price. So ideally for you as a deliverer, you would love fixed price, fixed scope, easy to define what everybody needs to do, but times change, especially in technology. So that's some interesting comments on that. And I don't want to read through this whole thing, but this guy sounds kind of interesting. Might be kind of fun to read through that. I might come back to him. So back to our plans for today was to look at the whole idea of estimating the total cost of ownership. Let's take a look at that in the book where they talk about total cost of ownership. As we go through, they talk about the various models of development. Wait a minute. This isn't the right chapter. I think I'm in the wrong chapter here. Somehow I jumped ahead here. Where's my table? Oh, it's slid over to the left. There it is. There it is. No, we're in the right spot. We're looking at, oh, not phase 4. We're going, goodness, we're not in phase 4. We're in chapter 4. There we go. How do we get all the way to page 500? Version 8, it should be. Yeah. Now we haven't talked about all these modeling tools, the case tools. These are going to be coming up in the chapters. We're going to be making a functional decomposition diagram for this chapter. So let's look at what a functional decomposition diagram is, and then we'll review, or we'll get a preview of what we're going to be doing in future chapters. For a functional decomposition diagram, as we start to model what our system needs to do, as we plan out, we've got the initial requirements, the reason we're going to pursue this project, but now we need to nail down the details of what the system is going to do. And that's why the RAD and JAD and Scrum approach talk about, okay, now need to fill out our system requirements and analyze it. One of the first things to do as you start thinking about a system is, what does it need to do? And that's the functional part of it. Functions mean things it does, the things our system does. And the diagrams, decomposition means breaking it apart into little pieces. Anytime you approach a problem, breaking it apart into smaller pieces helps you keep your sanity. It doesn't become a whole, oh man, we can't do this, there's just so much. Breaking it down into doable, estimatable pieces, remember the total or the cost estimate. And with a diagram, it just is a common way of displaying the function. This here is not a functional decomposition diagram necessarily. Well, it's things that are done. It's more activities that are done, and we're going to get into that in the use case. And let's see, I'm not sure if they give us, there it is. Here's our example functional decomposition diagram, kind of like an org chart of a organization. Here we have kind of the org chart of a system. And they've kind of set things at different levels. And you can see how they come to one part and it's got a lot of sub pieces, so they break it apart into smaller pieces. And some parts of that they break down into even smaller pieces. So the whole idea of managing a library, let's just look at this functional decomposition, see how they did it. They break it first of all into, well, what does a library do? Well, you handle people, handle the money, you operate managing the books, and you get money and you you find new patrons. Well, in the library management, most of the work in the complexity of the system is in operations. I'm sure, though, you could break down more sub-pieces of these other functions, higher level functions, like fundraising. We have to go find donors. We arrange for events. We put out brochures. We update the website. There's lots more things you could fill in on each of these boxes. So they're focusing on the operations, where okay, we also have to budget our books. You'd think that that might be part of financing, but they put that under operations. We manage the books in the library. We manage the personnel. And then looking in detail under book management, where we're getting in new books, throwing out old books, checking out and in books as patrons take them. We keep the history of the checkouts. We update people's profiles. And we may generate some reports for the people for accounting. There's probably more functions underneath book management. Repairing books. That may be part of checkout and return, a sub-item of check for damage and then send it off to repair. You could even break down these individual parts. All this diagram is doing is helping everyone, again, be on the same page of what the system needs to do. We're going to be doing this for our TIMS case study. But as we go into further chapters, we're going to be laying out diagrams called use case diagrams. I'm on a page ahead. Let's zoom out a little bit here, or my pages go wacky. Data flow. Here's the use. No, sorry, we're not doing the first thing they have in the book is a unified modeling language. No, data. This is the data flow diagram, and then unified modeling. Data flow diagrams is a way of breaking apart the processes in order to make those functions work. It's almost like a different look at the same kind of things in your system. We're going to be doing some of these as we get into further design and analysis of what needs to happen. And the important thing about these diagrams is carefully following the rules about each line represents information and each little box represents a function or something that happens in the system. And then it will typically, in a software project, each little box will become a software module of code that does the specific things, the arrows representing parameters or information it needs to get out of a database. So by carefully constructing the design, the software, the actual code for the software may actually fall right out of this. Even the names of variables might fall out of the proper construction of a data flow diagram. Another diagram then that we'll be doing is use case diagrams, which is discussed here. They don't even show a. Do they show a UML diagram? I'm not. Let's see if they show that on the next page. This is our data flow. This is our functional decomposition. They skip a UML diagram. A UML diagram, it looks a lot like a data flow diagram, where each little box is actually the name of a software module. So very similar to a data flow. The use case diagrams is more of a, what would you call it? More like a flip chart of here's what people do in the system, like a little cartoon diagram showing what the actors do, very much user-oriented of how people interact with the system. Even with silly little stick figures is actually part of the official use case diagram method, showing how people interact with the system. Now, if this is a system that's like a business to business, there may not be people involved, but the little stick figures might represent the accounting system pulling information out of our TIM system, where then we would characterize another external system as a little stick figure. Remember, all these diagrams are for getting everyone a nice understanding of what's supposed to happen in the system. And we're going to be building those as well in the future chapters. And the last diagram they talk about is a thing called a sequence diagram, which is kind of crazy looking. It's similar to what I've seen as called ladder charts in embedded controller programming. Is kind of from in a time sequence, top to bottom, things that happen between functions in our system. A sequence diagram, very, very carefully examining what has to happen one by one. Sequence diagrams are important when especially when you're dealing with a database, where you can't do the next thing until the data has been entered and validated in the system. And in databases, sometimes they'll do things like queuing up activities within the database. Well, you better make sure the queue is empty before you perform another step that's critical to having all the data in there properly. This is not so hard when you have one user, one computer dealing with one database. When you have multiple users from multiple systems interacting with a database that needs to be synchronized with another database, then you better be sure all the data is in before you go to the next operation. So with larger systems, synchronizing the data makes your sequence diagrams a very important thing to learn about and lay out when you're designing a system. So those are the various diagrams, but we're going to be doing a functional decomposition diagram. But first, let's go to our case study and look at our system requirements, because we want to get those finalized. And I think I have them up here in the notes here. Let's make sure I got them up there for you. This is our ongoing state. Let's see, we have requirements. Where did we talk about? There's our requirements document. Yep, I did put my notes in there. So if we look at our ongoing case study, not only do we want a system decomposition, functional decomposition diagram, they also want us to list the system requirements. Now in the book, if you have any trouble with some of these, like we haven't put anything in for performance and controls, let's go ahead and I'm going to copy paste this out into Notepad, and we'll be adding to this. If you click on the case study for chapter 4, requirements FDD. In the case study, I'll just bring up that online case study here. Let's go back to the go up to the online case study up here. It's also in the book at the end of the chapter. SAT8 is the password. In the session 4, oh, I guess it was our inbox, I think. Let's go back to our inbox. System requirements. The fourth item that Jesse wants was a list of system requirements. And I basically copy and pasted that into the assignment description. Now in the book, there is a page of example starting on page 150. There's example inputs, process, performance, and controls. So if you have any confusion about what are they looking for when they ask for a process example, take a look at what's on page 150, kind of an example of a process. And actually, this one's not a bad one for our system. The student record system must calculate the GPA at the end of each semester. Well, since we're not a college, we're not generally doing a GPA necessarily, but I'm sure students will want a transcript and maybe an average score, or maybe their manager that sent them and paid for their training wants to see how their student's doing. So we could add that to our requirements. So let me go back to here and let's paste in the requirements we had from last time, and you can help us fill in this table. So here's some outputs that Hannah and I came up with as we read through some of the documentation they had. The initial press release, we looked through that, and some of the initial forms. So we have verify records for former students, and I just see in the book there that having a student see their transcript and their GPA. So let's go ahead and as a process, the example was the student record system must calculate GPA. Okay, so let's call it records system needs to provide transcript, and what do I call it? Grades. Other examples in the book for a payroll system would be to produce a process and produce the data required, and then an output would probably be that report of the data. Do we have an output?
Was the temp system require a control of how it works? System works out?
Let's see, the TIM system, does it do accounting? Well, we could add that as a process. Might as well, and at this point, and it may be something that's discussed in the design, is we can keep track of hours, right, of students and how many hours they've taken. It may have, and if that's all the teacher's doing, they can actually be recording their hours. So maybe we could put in here, record, and maybe not limit it to teachers. We'll call it record employee hours spent, and generate reports. We could do the same thing for student hours. That we know how long they've been logged in and participating in a course. We could keep track of student activities. I'll say record and report student activity. Similar to reporting their grades, but maybe even more detailed. What pages they've been visiting. Have they made progress on their homework? In our eLearn system, we have some capabilities like that, where in certain activities, I have a completion setting, and when the is set, you see a little box next to an activity. And I've been experimenting with that. That's been a feature that I haven't used yet. I can set it for, you can just check it off manually when you're completed, or I have it when you've visited a link, it automatically becomes completed. I think it'd be cool that it somehow knows that you watched the video, or I can even make little what they call lessons that Maybe you see a video, answer some questions about it, successfully answer the give the right answers, then it automatically shows complete. That's built into this Moodle project. That's something that we could do in our TIM system, is in the student activity actually see that they've been online. And this, of course, involves logins and making sure they're not just faking it. They don't have a little robot pretending to be them going through the course. It'd be a silly thing to do, but some students, I'm sure, might try something like that. So we've got several things built up for outputs, inputs. How about performance and controls? And then we'll go to our functional decomposition diagram. What do we want to put for some performance and control activities? And in the book, we have some examples here. "25 users online simultaneously" doesn't sound like a terribly demanding. So that might be something we would want in performance. I'd say I might bump that up to 250. 25 doesn't seem like a whole lot. I've heard that access databases start to slow down. Well, this is a few years back. After 10 users, access databases that you put online actually begin to slow down. I've never actually tried that recently with an access database, giving it public access. It'd be fun to see with Office 2013 and faster computers how that does. So both of these seem like reasonable. I'd say exceed 4 seconds. I'm thinking 4 seconds is pretty long. I would want maybe 1 second. And maybe for big reports, but I'd say average response time less than a second. I think people are becoming more demanding. This is definitely a good 365 days a year, 24 hours a day. We could even specify, there's going to be, I'm sure there's going to be downtime for upgrades and things, but we could aim for, less than so many hours of per month of downtime. And with Hannah managing our servers with live migration and things, we'd be able to do a live migration and upgrade without any downtime, right? And that'd be a dream. I think even with Hyper-V, when there is a Windows upgrade, it just has to do a restart. I don't think there's a way to do some upgrades without some downtime. Is it conceivable that you could do a live, well, let's see, if you did a live migration, could you upgrade one? Well, I'm thinking anytime if there's activity on the system, you have to stop that activity before doing something. Otherwise, you'll lose the activity if there's a major upgrade. Maybe someone's figured out a way to actually upgrade live, do a live upgrade of major components. I just don't see how that could be done. But with hardware, Hyper-V allows you to actually have a new system with new hardware, do a live migration to the new hardware, right? If you've prepared your new system with the operating system fully updated, you can, or with the hardware updated, you can do a live migration to that new hardware while the system is still functioning. Pretty slick, giving you the possibility, especially for something like a bank, to be able to fully operational even while you're upgrading systems. Uh-huh. Yeah, most of the time, and I'd say it's more common with Linux systems. They seem to have their act together when, if there's not something that's a major change to the kernel, the operating system, you don't need to reboot. I think with Microsoft Windows, I think there's a lot of pieces that are more tied into the operating system, that when you upgrade this piece, because there's so many, there's 5,000 services running, and they're all dealing with other pieces in the operating system, sometimes it's a cautionary thing that we do a restart just to make sure that it comes up from reboot. That I wonder how many times that a restart is not really needed, but they do it just to make sure. But when there is a kernel upgrade, that the operating system, the basic code for the operating system, that it's so integrated in with everything happening on the system that you have to stop it once you've done an upgrade. That's really the only time that a reboot is absolutely needed. That there's a major bug found in a very low level piece that just affects everything. And because it's being used all the time, you can't install it on the fly. Because it's like, say it's like a file writing thing. That there's say you find a major bug in the code that writes data to a file. Because you're writing and reading from files constantly, there's no real way to fix that code without stopping all file operations. And the only time you can stop all file operations is doing a reboot. So that's the only time you should really need a full system reboot. But there's enough, just because they're written by people, there's enough errors here and there in that code that even Linux systems that are pretty rock solid need a reboot. The only times systems that haven't needed a reboot is they're a simpler form of Linux with only some very basic processes running, so limited amount of code running. They can claim to run for years and years without any reboots. Well, going back to the example, like say a major file, a code for writing and reading from files. They fix that code. The only time that you can make that change and put in the new code is once everything is done writing and reading to files, which is probably at a system shutdown. So at a shutdown, everything stops, and the very last thing you do is upgrade that piece of code that controls file writing. And then rebooting, everything starts up again. Sometimes you'll see that in Windows too. You'll say updating and then shutting down. Sometimes then you restart it and you'll see, oh, updating system before a restart. Well, what they could do in the code is, okay, they show what needs to be changed. Like in Linux, where you're updating the kernel, you have the new copy of the kernel ready, the operating system, and you tell the system the next time you start up, use this new version of the kernel. So it shuts down, then when it starts up, it starts with the new code. So the new code is ready to go, but doesn't get implemented until the restart. Because the operating system, again, is so integral to everything that's happening. You know, the display of the screen, the tracking the mouse, reading from the internet, all is in the kernel, critical code. You can't get the new stuff in there until you're starting over. But you try to avoid those kind of fixes, but occasionally you need those. And on our server systems, I automatically have an automated update using cron that I think daily checks for security updates. Those have to happen automatically. All the other updates, upgrades to software, I schedule and manually perform that in the system because I need to know what's happening. You don't want your system breaking in the middle of the weekend and it was some trivial font change. But if it's a critical update, like people can hack into your system until you put in this fix, you probably want that getting fixed, and you're kind of trusting the software people that they're giving you upgrades that don't break your system. Occasionally you do get an automated update will actually break a system. So system administrators always have that backup plan, that even if an automated update comes in, could I get back to my state yesterday before that happened? Out there in the banking industry and people where they're super dependent on the server running, what they'll do is they will have a clone of the system, test the upgrades on that clone, And then after it's all tested, then they'll actually perform the upgrade to the full system. And that's where virtualization makes that so much easier. I can very quickly clone a system in the virtual environment. Have my test users go and make sure all the base tests are performed, what they call benchmarks, before I even roll out a new change. It takes a lot of money to do that, because you have to pay people to go through, do all that testing. You have to have equipment that can handle all those clones of systems before you do upgrades. It's a major pain for people. So another performance things we could put in is and that may be in the details of being operational 365 days a year. So looking at a performance here, there's a lot of things behind that one statement. But we can put that in our performance. So back in our performance for our TIMs, we could probably take these first. Let's see if I can copy that whole section there and put it in here under performance. And let's see if how it comes out right in the notepad. Oh, not too bad. I didn't know Notepad would take bullets. I had little bullet items there. I would bump up my 25 to 250 or even more, and I would bring down my response time to 1, and maybe I'll say on average, because there's going to be times and this is our goal, but we know in reality there's going to be some downtime for upgrades. Any other performance, as we've been looking at examples, here's another good one for a student's record system. Produce class lists. That's not a bad idea. You think of some other performance things for it. Suppose you were involved in an online system like this. Can you think of any performance things you'd want for something like this e-learn systems that you're using? Have you seen issues from home regarding response time? One issue for me that I wish I had was when I made a schedule, the assignment schedule in Google Docs, that it would automatically transfer into my assignments here. I have to do multiple entries. That may be more of a input. Here's my dream input. Google Doc student schedule, or sorry, assignment schedule. Syncs with assignment settings. Right now I have to manually modify each assignment one at a time, where in Google Docs I can look at it in a spreadsheet and move assignments as we want to take a little more time in a section. I have to go remember to manually come in. So what I've basically done is I've turned off the due date assignments settings in Moodle, so they only show up as due dates in the lists. Problem is then you don't see the reminders in Moodle. So I've thought of writing the code to do that, but I just don't have the time. It'd be a fun little project though. Read Google Docs, run the code that updates the database for the class assignment. So students would register. So that's a student record system. We're not a student record system. We are a TIM system. So I'll put TIM's system. Or you could just say the system. You don't have to always give it the title. How about controls? What kind of control examples do we have here? Well, logon security. That's the basic thing we're going to have. I guess I'm not going to worry about the operating system level. I'm assuming that. I guess we could use this whole statement. Log on security, that's something you just come to expect of any system online. And instead of application level, I might say website logon security. And then say and at the website logon security and system level security. That would be back-end login for software updates and things. I'll call it root access to server. That's something that just almost goes without saying at the system level. In their example of controls, let's see. Well, there is a different level of security. You know, students can only read or view the courses and submit assignments, but teachers need to be able to modify courses. So access, what do I call it? Authorization levels. I don't think I'd call it security levels. I'd call it authorization levels. So oops, forgot to copy. So here, authorization, separate authorization levels for users and teachers. Well, actually, users, teachers, I'll call them, instead of users, I'll call them students, teachers, and admins. And what you're seeing with a lot of systems like this is instead of authorization, well, you'll have authorization levels, but it's based on role-based authorization. Where students, you can say all students can do this. You don't have to go one by one saying these are the students that can do this, that can access a particular course. These are the teachers that can do certain things. You have different roles defined. You have administrators, and you put people in the administrators group. It's kind of like Windows Active Directory. You establish groups, and you put people in those groups. In systems like Moodle, we call those roles. That a administrator can do certain things, and you decide who the administrators are. Teachers can do certain things, so you can establish what teachers can do, and then you can also establish who are the teachers. Very common in a system, learning management system, or even a content management system. Can we think of any other specific controls to your TIM system? Remember the controls, again, it's just a way of making you think of the various functions in the system. These aren't the only categories, but it's a good place to start of different categories of behavior of your system. So I think that's a good list. If you have other items that come to mind, feel free to add your own input, your own ideas into the five input, outputs, inputs, processes, performance, and controls. The 5 categories of system requirements. So that might involve an input where systems can upload assignments. And with assignments being uploaded, the process may be the system stores assignments in a secure manner. So that would be a process we add. We could even say encrypted. We'll call it stored in an encrypted format. Because we've got some security students that are wanting to break in and read everyone else's assignments. They figured out how to break into the system. So we're going to encrypt it. Anytime you add encryption, you always have the danger of losing encryption passwords and then not being able to get into your system. Maybe we want a master decryption code, which often systems will have, just because once you encrypt, you know people are going to lose that password. It's just going to happen. Yeah, so good idea. So some basic, you could even go further into teachers can enter, provide design pages for classes and create courses. So that would be a teacher can upload class material, and ideally teachers or course designers can import course modules. That is something that Moodle can do, but I think they've stolen the ideas from the more expensive learning management systems like Blackboard, and even book publishers. Certain books have a course module that comes with their book. You pay more for the book because there's some work that goes into that, but you get materials for each section. You get the tests to go with each quiz. You have test banks. A lot of time saved for your teachers, and then the teachers can customize that to their students. With our systems here in the Moodle system, I usually get a book. Many of the books I get have question banks, but that's all I get, and I have to import the banks, and from the table of contents I'll typically make the assignment schedule, and that's how your cs412 class has been created, from that table of contents from the book, and imported test banks for those e-quizzes or practice questions. And don't forget to take those e-quizzes. Okay, let's get on to the functional decomposition diagram. So I will copy paste this up here. Now what you want to do here in the assignment, what they've asked for is, let's see, here's the assignment. List the system requirements. Maybe just put a lead-in header above that saying, as requested, here is our list of system requirements. Now, functional decomposition diagram, we have to think about what happens in the course in the function, and I actually have listed from a previous class some ideas of main functions in the TIM system. Let me update this with at least our new list of system requirements. So from that decomposition diagram list, what you want to make is a chart. And I suppose the easiest thing to use would be, well, you could use PowerPoint because it has nice connectors. You could use Word. You could also use Visio if you'd like. So here is the assignment description. I'm going to replace the output description. Let's see. List from 217. Here's some outputs, or here's our new list copied and pasted from our ones we just discussed. So here's our new list, updated. Now that's not exhaustive. If something comes to mind as you produce that list, feel free to add it in there. Alright, so we'll save that. And now our next task is to create that functional decomposition diagram. That should look something like this. We're looking for a diagram like this for the TIM system, for a training management training, I forget what TIM stands for now. Training something management system? Is it training information management system? I think that might be it. Think about, and we have a list of some of the things going into our system. Let's see. I'm going to use PowerPoint for now because it's just easier to bring up. And I have the list of initial thoughts on main functions. So there's our main activities or functions. That's not exhaustive though. And I'm going to bring up PowerPoint. And let's see, I'm going to put just one page here with a title. I'll call it Tim's FDD. Huh? Yeah. Yep. That'll work. Yep. You can do a screenshot and then put in your main Word document, or let's see, am I allowing multiple documents here? If you have more, I'll bump it up to 5. And I've been having issue with file size here. There. Course upload limit, so file size, no limit on the file size. I was having issues with another class regarding file size, rejection of files that were bigger than 1 meg. Okay, so our FDD, we're going to be creating a chart that looks something like this, listing our different functions. So what you have to think about is kind of top level to low level, break it up into subparts that are manageable. And so from this list here, I have a few things: managing students, scheduling, registration. We'll throw those in there and then throw some other functions in as well. So with PowerPoint, I'm going to insert one shape and then get it all formatted and then just copy paste and change the text in it. And I'll make it similar to what they have. They do have a parallelogram. I'm not sure how strict the shapes matter. Let's see, down here in the flow chart they have some. If you use Visio, Visio has a whole class of I don't know if they have functional decomposition diagram. It's a standard enough. We'll use the parallelogram like they did in that exam. Oh no, they weren't parallelograms. They were just squares. Well, they're kind of boring squares. Let's try maybe a rounded corner. Oh, I kind of like that. That's kind of cute. And I'm going to choose my design right away. Or sorry, the style of that. I'm going to choose a quick style, something fancy. Conservative gray. Oh, we'll go with a orange today. And let's see, what do we have for some of our functions? Well, very high level, manage students. Control A, make a nice readable text, not too big. I'm going to have more boxes like this. I think I need to shrink it a little bit here, make room for more. That might still be a little big. Let's shrink it a little bit more. There, I think I have room for more boxes. So I like that guy, so I'm going to copy paste him. And now what do I have? Classes, manage classes. That's kind of on the same level as manage students. Student registration, that would probably be something underneath students. So put registration. Let's see, we need to register the student themselves and register them into classes. So how about register students? I'll call it register new student. And then we also, once the student's registered, we need to get them into classes. So enroll students into courses. Into course. Well, that kind of is an overlap between managing a student and getting them into the class. Maybe I'll put that kind of in between here. Maybe they're both sub items of managing classes and students. Try to make them the same size when I can, just to make it presentable. Transcripts. That sounds like a student level, so produce transcripts or transcripts. What did I say? Produce transcripts? Now I haven't connected them yet because I'm not sure of their level yet. Just kind of throwing in what we have. Certificates. Oops. Print certificates or diplomas. How about diplomas instead? That sounds more professional. And track grades. Oops, how did that happen? I'm not quite sure what track grades means. That seems a little bit abstract. Not sure, is that definable as a function? Let's see. So we're managing students, managing classes. How about teachers? Somehow we have to get teachers in and enroll them into classes. So would that be maybe a higher level manage teachers? Oops. Or instructors. That's a more common term for the teacher. And what do instructors do? What are kind of some of the activities involving instructors? Yeah, so they'll be and somehow being able to manage grades. So enter grades. Maybe it'll make it more generic. How about activity? How about activity management, or what do I call it? Activity. I guess management is the term. Activity. Assessment. Oh, assessment's a good word. Handling grades as well as have they turned it in. Is it available for grading? They also need to enter grades, and that would be under actually I need to break this in activity. I guess I'm going to go back to the activity management. And underneath there, they're creating activities and they're assessing activities. So I'm going to add two sub-items underneath there of activity, create an activity, a paper or a quiz, and then grading the activity. Sometimes the system will do it automatically, like the e-quizzes do for us. Other times the teacher needs to grade a paper. So I'll call it activity assessment. Now underneath activities, if we wanted to get into details, we could actually detail the variety of activities like quizzes, written assignments, external activities like they're assigned to go read a chapter and they check in that they've done it, or they visit a website and view a video. That would be another activity that, like we have on a completion here, once they've seen the link, it marks it as complete. Let's see, I'm just going to make them visually the same size for now. I think I can select everything and just make them all the same height. Let me do that. I can go to format and make them all, let's try 3/4 inch, 0.75, see what happens. There, now they're all the same height. Let's see, so student transcripts, registering new students, enroll students in the course. Kind of got a lot of activities. Trying to now kind of sort them into logical connections between higher and lower level functions. And with PowerPoint now, with connectors, I can connect them and move them around if I need to. So let's see, manage instructors, manage classes. We need to do same things with instructors of enroll instructors or assign instructors to course. So I'm going to copy paste this. To a course. And maybe I'll change the font size so I don't have to change my box sizes. And I'm thinking that's instructor management. So you can imagine doing this in a meeting with multiple developers, discussing how it all falls together, what things go where. Do produce transcripts, or do enrolling a student in the course, is that a course management activity or is that a student management activity? Let's see. Activity management, that might fall more under a course. So enroll students in the course, produce transcripts. I'm going to put those under more student related functions. Enroll students, that sounds like class. And let's see, activity management. Let's see, yeah, so I might put that over here more close underneath classes, and instructors over here under manage instructors, and under activity management, create activity and activity assessment, tracking grades, actually produce transcripts. That probably comes beneath tracking grades. I'm going to put that lower down. And I'll put tracking grades at that level, and printing diplomas and producing transcripts I'm putting underneath tracking grades. Now we haven't done a whole lot of details here, but you can see how going through functions can easily get to be a pretty complex chart. But for now I have some basic activities. Let's see, can you think of any other activities to add to this? And one way to think of this is think of the use case of a student comes and registers. Okay, so he goes through the registering it as a new student. He then sees what courses are available. And then enrolls into a course. Could be self-enrolls or they do a request. Now at some point the student needs to complete and upload his activity results, just like you turn in your assignments. So I am thinking of adding some functions of being able to complete an activity by the student. So the teacher creates the activity. I'm going to put over that underneath teacher, where the teacher creates an activity. And I'm going to add another activity or a function of the student completing and submitting the activity. So they have to be able to turn in, they'll complete a quiz or upload their assignment. Then the teacher can grade it. And activity management, I guess that should be over here under activity management. And as these get more detailed, you could probably break out these functions onto a separate page. But we're going to try to keep ours on one page. So there's where the student's turning in the activities. They're in a course. They complete an activity by submitting or just viewing the website. The instructor grades it. I guess for now we'll leave that at that. If you come up with others, add the boxes. All that's left for you to do now is connect them. And as you start connecting them, you may rearrange them. And then you'll have your functional decomposition diagram. So we'll stop it there. You can adjust to, as you come up with other activities. I'm going to center this, give it a nice look. The rest is more giving it a nice look, connecting things, and with PowerPoint I can make a nice little connector. But we are done. They don't need wires. You can choose curved or straight lines. I think I'll go straight lines. And I can copy paste my the original connector. And as I move around activities, they'll stay connected. I don't think there's a rule that you can't connect two things to one function. So managing classes, enrolling, and managing students, you could do a connector from both. As far as I understand, that's not a rule that you can't connect multiple things to a function. So I could have managed classes also connecting to enroll students. As you get into the other diagramming techniques, there are more strict rules to follow. I don't remember strict rules about functional decomposition. So connect them together, come up with any others, and we'll send that in. Have a wonderful day.